figure this out. I gotta draw things. Here's a triangle, and they're saying it's a triangle DEF, and it has a vertex of where F is. Let's call this F. It's a 9-degree triangle. So here's your triangle, the vertex right here, F, 9-degree triangle, and this is D, and this is E. They also say that DF right here is 9 and FE is 12. So they're looking for the distance, the side length DE, which in this case is our hypotenuse. So let's call this A and let's call this B, and the rest is just plugging it in and solving it. So A squared plus B squared equals C squared. We're looking for the hypotenuse. A is 9 squared, B is 12 squared equals C squared. So that's 81 plus 144 equals C squared. And 81 plus 144 is 225. And lucky for us, they give us a nice pretty number. Take the square root of both sides, and C, for our intents and purposes, is 15. So this C measures 15. Alright, so just notice that's relatively simple, yeah? The important part was labeling a triangle correctly. We have another triangle, and it says hypotenuse at 13, one of the legs is 5, one of the legs is 5, find the missing leg. Let me just point, make this guy a little bigger. Let's label this, call this A, let's call this B, and let's call this C. So we can use a Pythagorean theorem to find either the hypotenuse or the leg. In this case, we want the leg. So A is 5 squared, B is what I'm trying to find, so leave it alone, and C is 13 squared. 25 plus B squared equals 169. We're going to subtract 25 from this side and subtract 25 from this side. So B squared equals 144, and again another nice perfect square. Take the square root of both sides, and B is 14. So the answer is 14. Not quite. Sorry, not 14. Oops. Wow. 12. Thank you. No. 12. Ouch. Again, well, not again, because I have no idea what the question is. So let's select the legs of this right angle triangle. So they're asking you to identify who's the leg and who's the hypotenuse. So remember I told you the easiest way to do this is to find the 90-degree angle, which is clearly labeled here. So that's 90-degree angle. From the angle, I need you to draw an arrow and point it to the opposite side. So the 90-degree angle is pointing to the side F, which makes this C, or the that are known as the hypotenuse. C being the hypotenuse of the longest side of this right angle triangle, which makes the other two sides, D and E, the legs. These are the legs, or if you were to plug it in your formula, they would be A and B. So select the legs of this right triangle. So we're gonna select D and E. They're both legs. What is this? And they're asking us here in this particular question, is this a right triangle? So it's the converse, right? So the converse says that if A squared plus B squared is C squared, then we have a right triangle. So we don't know. And notice that they didn't put this little symbol over here, because we don't know yet if that's a right angle triangle. So they didn't put the little square in the corner. So there's a possibility that it might be. So let's figure it out. So like again, let's identify the parts. This is the leg, so this would be A and B. And this, the longest side in the right angle triangle, is the hypotenuse, and that would be C. So now, let's plug it in. So we get 7 squared plus 24 squared equals 25 squared. If both sides equal each other, then we have a right angle triangle. So that's 49 plus 24 to the second power, which is 576. And then 25 to the second power is 625. So let's add them up and see if it's truly a right angle triangle. And look at that, it is. So A squared plus B squared does indeed equal C squared, right? Because we've got 625 equaling 625. So these three sides do make up the sides of a right angle triangle. So yes, it is. Let me drag this guy. Use the Pythagorean theorem to find C. All right. So again, a little bit repetitive, right? So now we know that's C because it's the side opposite the right angle triangle, which makes these two A and B. What is the question saying? Use the Pythagorean theorem to find the length in feet. I don't know why they did all that. So we get A squared plus B squared equals C squared. 3 squared plus 4 squared equals C squared. 9 plus 16 equals C squared. And notice they're giving us pretty numbers, right? So perfect square, so 25 is a perfect square, so take the square root of both sides and C equals 5. 6, and we're now in this case trying to find B, one of the legs, right? Because again, start with this, make a little arrow, identify that this is the hypotenuse or C, and then this guy will be A. So we're looking for B. So A squared plus B squared equals C squared. A squared is 4.5, take that to the second power. B squared stays. C squared we can substitute with 7.5 to the second power. So 4.5 to the second power is 333. Whoa. 4.5 times 4.5 equals 20.25 plus B squared, and then 7 to the second power is 56.25. We're going to subtract 20.25 from both sides. That eliminates, becomes 0. So B squared equals, that's 0, and that's going to be 36. And then if we take the square root of both sides, B equals 6. Yeah. All these pretty numbers they give us. 7, a word problem. So here is the ship. Let's make that the starting point. It travels 21.35 miles east. So east is this way. That's 21.34. And then it travels 15.89 miles north. How many miles from the starting point has its ship traveled? So this would be in the ship. And let me just draw a little ship. So the ship is right there. So how far has the ship traveled? Well, obviously we're going to take the shortest route here, and that's what we're measuring. So this is what we need. This is A and this is B and A, however you want it. Let's use the Pythagorean theorem, and so we get A squared plus B squared equals C squared. 21.34 plus 15.89, definitely a calculator problem to the second power is C squared. So you probably have to round this. So 21.34 times 21.34. Horrible number. We're not going to round, so please do not round. So if this was your test, you get 455.3956. Don't round that. We want to round your final answer. So 15.89 plus 15.89. Oops. Times 15.89. This is equal to 252.4921 equals C squared. So let's combine those two. Plus 455.3956. It's going to give us this really pretty number, 707.8877 equals C squared. We're going to square root both sides. And C equals, take the square root. And rounded, 26.61 approx. Let's see if that's what. Not quite. What? How many whole miles? Okay, sorry, I didn't read the question. So if we round this to the nearest whole mile, instead of 26, we get 27. Try 26. All right, let's try 26. No, not to the 6. No, sorry, let me erase this. 26. What in the world? So let me just verify my work. 2134 and 15.89. 21.34 times 21.34. 455, 3956. Okay, that's okay. 15.89 times 15.89. 252.4291. So we're going to add that to 455.3956 equals, take the square root of that. That gives me 26.61. I'm not too sure where the mistake is. So I'm just going to leave, well, if it says how many whole miles, the answer would be 27. Unless I'm missing something. Let's submit again. Not too sure why they're saying it's wrong. All right, I want to leave it this. If you can find, if you think you did it, if you find the correct answer and it actually works for you, let me know. 8. So the point T, so let me make this guy a little bigger. Point T is at -5 and comma -3. Let me make a dot right there. And then it's translated 8 units up. So we're going to take this point here and translate it 8 units up and then 7 to the right. So let's just count 1, 2, 3, 4, 5, 6, 7, 8, and then 7 to the right. 1, 2, 3, 4, 5, 6, 7. So this is T, and this is T prime. So the answer would be 2, 5. Good. That's easy. Point -8 and 7, which is right here, is translated 10 units down and then 13 right. So 10 units down, if you're at 7, you become a -3 right here. Can't really see. And then from here, I'm going to go 13 units right. So from here, I'm going to go all the way 13 from -8, which would give me to +5. So it would be here. So this is point Y, and this is point Y prime. So the answer would be 5, -3. So this one they don't have a graph. And we're talking, so give me the rules. XY, so we had a point XY, which in this case is -1, -5, because that's the one they're talking, right? So what happened to X and Y? It went 3 to the left and 8 up. 3 to the left means X minus 3, and then 8 up means the Y value increased by 8. So that's exactly what we're going to do. So we're going to go 1 minus 3, and then we're going to go -5 plus 8. Think about it. If you're on -1 and you go 3 left, where are you? I'm on -2. If you're on -5 and you go 8 up, where are you? I'm +3. And that's basically what we're doing. Not quite. What in the world? Find the coordinates of point A. Point 1 is -1, 5. It went 3 to the left and 8 up. 3 to the left and 8 up. Okay. So 1 minus -3, -5 plus 8. All right, let me write it like this. Okay, confirm the points. 3 points to the left, which means x minus 3, okay, and 8 up, y plus 8. And we're talking about point A and A only. So if you're 1 and -5, so if you're 1 and you walk 3 to the left, you end up at -2. That's okay. If you're -5, right, on the y-axis, on the y, and you go 8 up, you're at 3. -2, 3. Again, let me know if you find the correct answer. What in the world? Is there a help button? Give me a hint. Okay, let's see. Whatever. Quadrilateral WY XYZ is translated 4 units to the left. So if you're talking about translation, 4 to the left is x minus 4. and then 10 units up, which means y plus 10, right? So this is what happened to your x and y coordinates. Find the coordinates at point y. So let's look at point y. Point y is at 5, 5 right now. So let's think about this for a second. If you're 5 and you walk 4 to the left, and then if you're 5 and you go up 10, where would you end up? If you walk 4 left, you end up with 1. And if you are at 5 and you go 10 up, you end up with 15. Do I not know my left from my right? What am I? Four units to the left, 10 units up. You're on 5 and 5. Okay, I'm gonna ask someone else to see what am I doing wrong, but there's nothing wrong. Find the coordinates of point y. Next, which sequence of transformations? Oh boy, I can't read this. A, so definitely there's a translation. So first thing I'm looking for, it's, well, obviously it's a, not translation, dilation. And then look at the orders of A, B, and C. So if you look at, and you go clockwise, so if you go clockwise, right, look at the smaller triangle, the original triangle, it's A, and then C, and then B, right? So if you go clockwise. And if you go clockwise here on the other one, the bottom one is A prime, and then going clockwise, it's B prime, and then C prime. Notice that the order changed. So that tells me there was a reflection. So definitely a dilation, and then a reflection. So it says a dilation by a scale factor of 2. Well, there's a dilation and then a reflection over the x-axis. So C and D says a dilation by a scale of a half. No, it didn't get smaller, it got bigger. So it's definitely either A or B. So they're both dilation of 2, but one says reflect over the x-axis and the other one says reflect over the y-axis, across the y-axis. So definitely this was a reflection over the x-axis, right? So we want letter A. Oh my God. What sequence of transformation maps? Okay, so again, you know it's a dilation, right? It definitely got smaller. So remember, it went from here to here. How do we know that? We look at the prime. So this is A prime A, and this is A prime. So it went in this direction. Then we write the sequence. So we know it got smaller. So it's definitely a dilation by, and if you want to know what the dilation are, look at point A. Point A is 2 and 4. Point A prime is -1, 2. So notice that -1 and 4 and 2 is, what do you call it? It's half. So definitely a dilation of half. And then look at the order. Again, let's go clockwise. Let's go this direction. So A and then B is sitting next to A, and then follows C, and then follow D. If you look at the other rectangle, it's A prime, D prime, C prime, B prime. So the order changed. So definitely a reflection and a dilation. So a dilation of half, and then a reflection obviously over the y-axis. So a reflection, no translation, reflection over the y-axis and dilation of a half. B looks just right. Rotate it 9 degrees and then dilate it. Oh, shoot. So if you have a, let me try this. If you have a triangle, let's say the triangle's over here, and you rotate 90 degrees clockwise, and let me just write A here, B, and C. If you rotate this 90 degrees, it's going to end up here, clockwise. This is A, and this is B, and this is C. Sorry. A, C, B. Right? So there is your rotation. And then it says, and then dilated with a scale factor of 2. So if you dilate this, you're going to get a triangle that's twice the size. Right? So A prime, C prime, B prime. So that's what we're looking at. What is it? They are similar and congruent. Well, between the first triangle and the ending triangle, notice that they're not the same size, right? Definitely got bigger. So they're proportionally they're proportional. Their side measurements are proportional. So they're not congruent. So anything that has congruent is it's out. Okay, because they're not the same measurements. So anything that has similar, you might have a valid choice. But A says they're similar and congruent. That just can't happen. So A's out. B says they're similar but not congruent. That's right, right? They group proportionally. They're not congruent anymore. C says they're congruent, not similar, and D, they're neither. No, we want B. Select a triangle that represents the reflection of triangle X. So here's triangle X, so we're looking at this. This is my original. Across the x-axis. Well, this is the x-axis right here. So if you're going to reflect, it's going to go from here to here, and we want triangle C. That's easy. Quadrilateral A prime, B prime, C dot is a reflection of, okay, find the line of reflection. Remember, on the reflection, each point is equally distant from the line of reflection, so the original point A and A prime should be exactly the same distance away from your line of reflection, and we have to find the line of reflection. The line of reflection, let's see, 1, 2, 3, oh my god. Oh my god, because I can't see. And can you make this? You guys can make it bigger. Oh, I can. So my line of reflection, it has to be halfway between those 2 points. So let's see, 1, 2, 3, 4, 5, 6. So my line of reflection should be halfway, right here. So let's count from A prime to the line of reflection. It's 1, 2, 3. And then from the line of reflection to A regular A, 1, 2, 3. So my line of reflection, wait, let me make that a little prettier. My line of reflection should be this line right here. Right there. Final line reflection. Line of reflection is y equals -2. So y equals -2 is my line of reflection. Right, this line right here. Submit. Okay. 17. The image shows 4 different reflections. Which graph represents a line reflection across x equals 1? Well, let's find x equals 1. X equals 1 is right here. Right on the x-axis, 5, 1. So if I draw a mirror, are these 2 images the correct images after reflection over x equals 1? So this is a no. They have to be equally distanced from the line reflection. Let's draw x equals 1 here. Are these 2, look at Q and Q prime. Q prime is 2 units away from the line reflection, and Q is 3 units away from the line reflection. This is also a no. Let's do this one. If you count, Q prime is 1, 2, and then Q regular, Q is just 1, 2, 2 units away, and that seems to be the correct one. So for C, the red triangle and the blue triangle, they're both equally distanced from the line of reflection, the mirror, which is x equals 1. So click C. Point Q is reflected across the line x equals 2. So let's here. So they actually drew x equals 2 for us. What are the coordinates? Well, all you gotta do is count. So we got 1, 2, 3, 4, 5. So Q prime should be on the other side. 1, 2, 3, 4, 5. And this is Q prime right here. What's the coordinate? It's 7, 4. Oh my. Okay, 7, 4. Jeez. Triangle ABC is reflected across the line x equals y. Find the coordinates of A prime. So A prime, so again, remember when it's a diagonal, we go through the boxes, right? So we're going to go this way. And then this way as well. So A prime would be right here. And what's the trick? Well, if you remember the rules of reflection, when y equals x, the point here was point A. What was the point A? It was 1, 3. Point A was 1, 3, and then the rule of, what am I doing that? So under a y equals x reflection, all you have to do is switch sides. It's 3, 1, and we already knew that. Look, 3, 1. So remembering the rules comes in very handy, especially for y equals x, y equals -x, because sometimes it's hard to find the distance on the other side of the line of reflection. Point P of the triangle has coordinate 2, negative 2. What are the coordinates of point P after the triangle has been rotated 90 degrees counterclockwise? So, okay. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Remember, for every 90 degrees, a point travels one whole quadrant. So point P, we're going counterclockwise, which means we're going this way. So point P is going to land in quadrant 3. Okay? And it's negative 2 and 2. So if you switch, that hand trick, if you switch sides, it's still going to be 2 and 2, but in quadrant 3, who's negative? Everybody's negative. So point P is going to land right here. P prime, I should say. So 2, comma, negative 2. Negative 2, comma, negative 2. Try again. All right, negative 2, comma, negative 2. Is that better? I guess sometimes it's how you write it. Point P of the triangle has coordinate 2 and 4. Okay, what's the coordinates after the triangle rotated 90 clockwise? So again, if you're going clockwise, you're going from here to here. Point P is in quadrant 1. After a 90-degree rotation, it's going to travel one full quadrant, so it's going to land in quadrant 2. So point P right now is 2, 4. If you switch them, it becomes 4, 2, but in quadrant 2, who is negative? The y coordinate. So it's 4, comma, negative 2. Quadrilateral A prime, blah, 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 is a rotation of A, B, C, D. Explain. Is it a rotation or not? Well, let's look at point A. Point A here is negative 5, comma, 5. If you rotate this, and obviously A traveled 1, 2 quadrants. So this is a rotation of 180 degrees. Keep that in mind. So if it travels 180 degrees, A prime is going to be 5 and 5, right? But in quadrant 4, which is this, the second number is negative. So after a rotation of 180 degrees, A should become, A which is negative 5 and 5 should become 5 and negative 5. Is that true? Well, yes it is. Let me just do one more point. Point C. Point C right now is negative 5, comma 1. After a rotation of 180 degrees, you switch the numbers once, switch the numbers twice. It still becomes 5 and 1, but let's adjust the signs. C prime would be 5, comma, negative 1. Is that what's happening here? Yes, it is. So the answer is yes. Again, is this a rotation? Well, let's pick a point. Let's pick point A. Point A, oh my god, let me make this so tiny. So point A, let's look at point A. Point A is 2, comma 3. After a rotation, and obviously this is going this way, right? After a rotation, so it's 90 degrees. A prime should be 3, 2. But in quadrant 2, where it lands, the second number is negative. So if is A prime negative 3, negative 2? No, it's not. This is the correct rotation, but notice that A, which is 2, 3, is not 3, negative 2, right? So it should be 3, negative 2. Sorry. My apologies. It should be negative 3, 2, because in quadrant 2, the x is negative and the y is positive. Apologies. So it should be negative 3 and 2, negative 3, comma 2. Well, A prime should have been here. And it's not. So obviously this was not the rotation. Point XY is rotated 90 degrees. Okay, so we have point, what's the coordinates of point P? Also, if you have a point XY, right, and you rotate this 90 degrees, you can take any example. So if you have a point, let's say it's over here, let's call that point 3, 2. And you rotate 9 degrees, what happens to the numbers first of all? Well, first of all, they're going to switch, right? It's going to, let's say you rotate over here. So the XY, so now it's going to be 2, 3, so the two numbers switch positions. And guess what? And the second number is going to be negative. So it actually becomes Y, comma, negative X. And it's always nice if you drop an example, make up some number, and see what happens after a 90 degree rotation. Okay? Not quite. What in the world? Oh, clock. Yeah, I did that. 3, 2, 2 comma, negative 3. I don't like this. Oh my God. What is wrong with this? Point P, XY is rotated 9 degrees clockwise to point P prime. What are the coordinates of point P? Well, again, if you take the example 3, 2, you switch once, right? It becomes 2, 3, and guess what? In quadrant 4, you negate whatever x was, and it becomes negative. Alright, I'm moving. So if you find why I did it incorrectly, what am I typing? So let me put parentheses. Oh my God. Point xy, again, so again, I see how they don't give you a number, so pretend, pick another one, pick a very easy one. Let's pick 3, 2. So they're telling us that there's a point called xy, which we're going to pretend it's 3, 2. It's rotated 180 degrees. So rotate 180 degrees, 3, 2 changes to 2, 3, it becomes 3, 2 again, but it's going to be opposite sign. So P prime is going to still be xy, but they're going to be negated. Whatever x is and whatever y is, it's now a different sign. Triangle A was rotated 90 degrees to triangle B, right? Was select this true statement, or what was, I don't know what's true statement. Triangle A is congruent to triangle B, yes, and it would be this one. Oh, by the way, so if you look at this, this means congruent. Okay, that's what they mean. I gotta go to the next question. So let me just, that meant congruent. This means similar, by the way. Okay. Are the figures congruent? I have no idea. Well, let's figure it out. Are they congruent? Well, let's measure them. Well, it's definitely 90 degrees, which makes this guy here the C. 90 degrees and makes this guy C. Let's look at A. Well, let's make that A. A is 3. Is A 3 here? Yes, it is. What's B? 1, 2, 3, 4, 5, 6, 7. So B looks like 7. Is B 7 as well here? 1, 2, 3, 4, 5, 6, 7. Yes, it is. Select a series of transformations that transformations of triangle A that shows that it is congruent with triangle B. Well, a rotation followed by a reflection. Could this 90-degree rotation clockwise goes over here. Followed by reflection. So if I take that and rotate this, let's take a point. So let's make that 1, negative 1. 1, negative 1 rotated. Right? It's going to land here. So everybody will be negative 1, negative 1. So it'll be right about here. Okay. And if I take this point, which is 4, comma, negative 1, and again rotate it, it's going to be rotated. When I rotate clockwise, it would be negative 1, negative 4, negative 1, negative 4. And then this guy over here would be 4, negative 4 right here. So after a 90-degree rotation clockwise, it stays over here. Is that a reflection? Yes. So we want B. Transformation. Okay, so transformation of 3 units down reflected by, so if I take this guy 3 units down, I take this point right here, 3 units down, 1, 2, 3, and then reflect it, will it be on that side? A is not it. B, translate this 4 units down, okay? All right, so that's going to land here. All right, so if you translate this triangle 4 units down, we're in the same spot, okay? So we're good here. But then it says a reflection. No, that's not going to work because if it's reflecting, the triangle would end up like this. Or B would end up like this, so definitely not B. C says a translation of 4 units down, find and am I counting this wrong? 1, 2, 3, 4, sorry. So translation of 4 units down and 5 to the left. Let's see if that works. So 4 units down, then 1, 2, 3, 4, 5, and that looks like the correct one. 4 units down and 5 to the left. So C. What are coordinates of 0.10 after 9-degree rotation? So here's 1 and 0. You can always draw a mini coordinate plane. 1 and 0 is right here. Okay? And we're rotating this clockwise, so you're going to go like this. So when it's on the axis, it's going to go from here to here. Right? And it's a 9-degree rotation, so we switch the numbers. But guess what? Over here, it becomes 0, -1. A square has vertices. Rotate the square by 90 degrees counterclockwise. What are the new vertices according to vertex D? So let's look at D. 3 is a 3 and 1. And let's see what 3 and 1 here. 3 and 1 would be somewhere around here. Let's call that D. We're rotating to counterclockwise, so it's going to go this way. And if it goes that way, right, it's going to go from quadrant 1 to quadrant 2. And in quadrant 2, first number is negative and the second one is positive. So remember, 9-degree rotation, 3, 1 becomes 1, 3. But the first number, x coordinate, becomes negative, so it would be -1 and 3. So and that's where D prime is. So -1, 3. Next, an artist has drawn a design, and 7, -3 is about 7 to the right, -3. So let's call that 7, -3. Is rotated counterclockwise, so we're going to go this way. What's the new point? Well, we're going to switch it once, so 7, -3 becomes 3, 7, because it's only a 9-degree rotation, and in quadrant 1 where it lands, everybody's positive. So the new answer is 3, 7. Nope. Oh, sorry, the design is rotated 9 degrees counterclockwise about the orange 3 times. So 1, sorry, I didn't read that. Mistake, so let me take that. So this point is going to travel 1 quadrant over here, 2, 3. So it actually lands in quadrant 3. In quadrant 3, the x is negative, and so is the y. So, and traveling 9 degrees that way is the same thing as traveling three rotations that way is the same thing as rotating clockwise 1 that way. So switch the numbers, it becomes 3 and 7. But in quadrant 3, everybody's negative. So the actual answer is -3, -7. And -3, -3, -3, -3. So dilation, what's the scale factor? Well, to find the scale factor, we need a point. So let me drag this over here, this. Pick a point. Pick the easiest point ever. Let's just use point A. So point A is 1 and 1. Point B is 2 and 2. So notice that it's a dilation, but it's an increase, right? So how did 1, 1 become 2 and 2? Obviously times 2. So what is the scale factor? Let's multiply by 2. It's super easy. Again, another dilation. Right, definitely, and it got bigger, so it can't be less than 1. The scale factor can't be less than 1, because if it's less than 1, it would have gotten smaller. If it's equal to 1, the triangle would have been the same, but obviously greater than 1 because it increased. So we want that one. triangle XY. So what are the coordinates of point? It's going to be, oh, here we go. Point X. So look at point X. Point X is -3, comma 6. Right? So we're going to multiply both by 2/3. Right? So it's going to get a little bit smaller. So -3 times 2/3 is going to be -2. And then 6 times 2/3 is 4. It's going to be -2, 4. Remember, we multiply all the points by 2/3. So -2, comma 4. Series of reflections, translations, rotations, change ABC to this one. Which of the following is true? Well, BC is congruent to EF? No, because it got bigger. So ABC is congruent. So anything that's congruent is not true. Oh, sorry. Side BC is congruent to side EF. Not true. Angle ABC is congruent to angle EFG. Yeah, we want B. Right, because this angle right here. So basically they're saying angle ABC, which is this angle. Sorry. Next time. What's the ratio from the smaller triangle to the larger triangle? So the smaller. So pick a side. 6 from the smaller triangle. And we pick a side. Let's pick this side. Bring this up. So they're asking so ratio, right? We're comparing the smaller to the bigger. So pick a side, and let's just stick to that side. Let's pick this side over here. So the ratio from the smaller side, this side, to the bigger side, and that's the bigger side, right? Order is important. They're saying from the smaller to the larger. And 6/12 is just 1/2. What is the ratio from the smaller square to the larger square? And again, order matters. So again, we want the ratio. So put it as a fraction from the smaller to the larger. And we're going to use 28, the smaller to the larger. And in simplest form, we can divide by 4. We get 7, 7/8. Okay, so kind of a long video.